This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 6, Threads and Bolt Strength. Every earlier lesson treated a bolt as a plain shank in shear. But a bolt loaded in tension carries that load through its threads, and the thread reduces the area that actually resists. The tensile stress area, smaller than the nominal shank. This lesson does three things. It reads the tensile stress area off the handbook thread tables, decodes the grade and class markings that tell you how strong a bolt is, and finds the proof load, the largest tension a bolt takes with no permanent set. Two quick table lookups, one metric and one unified, that Lesson 8 will reuse for bolt torque. Here are the two problems. An M16 by 2 course bolt in metric class 8.8, and a 1/2 inch 13 thread unified course bolt in SAE grade 5. For each, find the tensile stress area, find the proof strength, and multiply to get the proof load. There's nothing to derive. The entire skill is knowing which table holds the area, which holds the strength, and reading the right row. These two proof loads carry straight into the next two lessons. Concept 1. The load rides on the tensile stress area, not the shank. A thread cuts a helical groove, so a bolt in tension doesn't resist across its full nominal diameter. The handbook defines an effective tensile stress area, sized between the pitch and minor diameters, and the axial stress is simply the load over that area. The key habit: read the area from the table. Never compute pi over 4 times d squared from the nominal diameter. That always overstates the strength. For an M16, the nominal disk is about a quarter larger than the true tensile area. Concept 2. The head marking is a strength code. For a metric bolt marked class xx.x, the first number times 100 is roughly the minimum tensile strength in megapascals, and the second number is the ratio of yield to tensile. Class 8.8, 8 times 100 is 800, close to its tabulated tensile. 0.8 of that is its yield. SAE grades work the same way. A higher number is a stronger bolt. On the exam, the head marking, radial lines for SAE, or a stamped number for metric, tells you which strength row to read. Concept 3. Proof strength sets the safe load. The tables list 3 strengths, and they always rank proof below yield, below tensile. Proof strength is the largest stress a bolt takes with no permanent set. Yield is where a small permanent set begins. Tensile is where it finally breaks. The number you design to is the proof load. Tensile stress area times proof strength. When a material has no tabulated proof value, the handbook lets you estimate proof strength as 85% of yield. But that's a fallback for untabulated materials only, not a check on the values the tables already give you. Setup Part 1. The tensile stress area tables. The area comes straight from the thread tables. One metric table in square millimeters, one unified table in square inches. Notice that at a single nominal size, the coarse and fine series give different areas. Fine threads leave a bit more material, so their area is larger. For our M16 course, we read 157. For the 1/2 inch course, we read 0.142. Always match the row to the thread series you're given. Setup Part 2. The strength tables. Proof, tensile, and yield come from 2 tables. The SAE grade table in KSI, and the metric class table in megapascals. Watch the grade 5 split. Its proof strength is 85 KSI up through 1 inch, but drops to 74 above 1 inch. A larger grade 5 bolt is actually weaker per unit area. The metric class sets its own strength directly, so class 8.8 is 600 megapascals proof across its M16 to M36 range. To move between the 2 unit systems, multiply KSI by 6.89. Solve. Problem 1. The M16, class 8.8. Tensile stress area from the metric table, proof strength from the class table, and the proof load is their product, about 94.2. That's the largest tension this bolt carries with no permanent set, and it's the number Lesson 8 will turn into a tightening torque. Solve. Problem 2. The 1/2 inch 13 grade 5. Tensile stress area from the unified table, proof strength from the grade 5 row for a 1/2 inch bolt, and the proof load is their product, about 12.1. Because the bolt is a 1/2 inch, It sits in the lower size range, where proof strength is 85, not the 74 that applies only above an inch. Area in square inches times proof in KSI gives the load directly in kip. Traps. 5 ways this bites. 1. Computing pi over 4d squared instead of reading the tabulated area. The nominal disk is a quarter or more too large and overstates strength. 2. Coarse and fine threads have different areas at the same nominal size, so match the row to the series. 3. Proof, yield, and tensile are 3 different columns. Read the one asked for. 4. Grade 5 proof strength drops above 1 inch, so check the size range. 5. Keep the area and strength in 1 unit system, square inches with KSI or square millimeters with megapascals. Quick recall. Read the tensile stress area from the thread table, never pi over 4d squared. The axial stress is the load over that area. Strengths rank proof below yield, below tensile. Pick the column the problem asks for. The proof load is area times proof strength. If a material has no tabulated proof, fall back to 85% of yield. Keep units consistent. Square inches with KSI, square millimeters with megapascals. And remember the 2 anchors, the M16 class 8.8 at about 94.2 kilonewtons, and the half-inch grade 5 at about 12.1 kip. Next up, Lesson 7, Tension Connections, Preload and Joint Stiffness. This lesson found the proof load, the largest tension a bolt takes with no permanent set. But a real bolt is tightened to a preload, and then shares any external load with the clamped members. Lesson 7 builds that picture, with the preload already given, how bolt and joint stiffness divide an applied load. The bolt feels only a small share, and where the joint separates. Lesson 8 then sets that preload as a fraction of the proof load, using the 2 values you just found, and turns it into a tightening torque. Everything's at PEPrepEngine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide, with every equation and common exam trap, is free at PEPrepEngine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.